Hello friends, this is the first video of acid-base reactions in organic chemistry, and in this video we will study about bond cleavage. So there will be some ionic compounds also in organic chemistry, but most of the time we will be dealing with covalent compounds. So in many of the organic reactions it is just the cleavage of the breaking of old covalent bonds and the formation of new covalent bonds. So we should have some idea how this bond cleavage takes place. So a covalent bond may break into in two different ways. The first one is heterolytic bond cleavage and the second one is homolytic bond cleavage. Now what are these? Heterolytic bond cleavage means the bond may break so that one fragment takes away both electrons. So as you can see here is a covalent bond between two atoms A and B. Now this bond breaks because of some reason and both the electrons of this bond is taken by B. So B gets a lone pair, because of which it gets a formal negative charge and an empty orbital A has. So it has a formal positive charge. One fragment takes away both electrons of bond, leaving the other fragment with an empty orbital. So here A has an empty orbital. This kind of cleavage called heterolysis produces charged fragments or ions. So as you can see here that before the cleavage these two are bonded together and no charge, but after the cleavage we got ions, that is charged fragments. So this is heterolytic bond cleavage. Now the second type in which bond can break is the homolytic bond cleavage. The bond breaks so that each fragment takes away one of the electrons of the bond. So as you can see here that this bond breaks and one electron is taken by B and one electron is taken by A. And notice also here that the arrow here was just arrow, and this is a general arrow. This is fish hook arrow, which denotes the transfer of the movement of only one electron. So what we get here is called radicals. So this process called homolysis produces fragments with unpaired electrons. These electrons, unpaired electrons, called radicals. So this is homolytic bond cleavage. So in this chapter we will mainly discuss about heterolytic bond cleavage. So now heterolysis normally requires the bond to be polarized. Now what do you mean by polar bond? So polar bond or polar covalent bond happens when the two atoms they differ in their electronegativity. Now what do you understand by electronegativity? Electronegativity means the tendency of an atom to attract the shared pair of electrons. Here B is more electronegative than A, B is more electronegative atom than A. That means these two electrons which are shared between A and B are not equally shared. B will pull this shared pair of electrons towards itself, but it will not pull the whole electrons, just slightly. So it gets a slightly negative charge and A gets a slightly positive charge because electron density shift towards B. So we call it partial negative and partial positive charge, and this kind of bond is called polar covalent bond. So for a covalent bond to be a polar, the species should have a difference in electronegativity. Okay, so the greater the difference in electronegativity, the greater the polarization. But even with a highly polarized bond, heterolysis rarely occurs without assistance. Why? We need some help for this bond to break, because the breaking of this bond means we are separating oppositely charged ions and they attract each other. This is the reason heterolysis requires the separation of oppositely charged ions. which attract each other, so their separation requires considerable energy. So there are many ways in which we can give the energy, but often heterolysis is assisted by a molecule with an unshared pair. As you can see in, in this example, uh, here is a polar covalent bond. A has partial positive and B has partial negative, but this bond will not break by itself. Third molecule with a lone pair. This attacks on the this attacks on this A, which has partial positive charge. So uh, so this A is getting some electron density from Y, and it has already some electron density here, so it cannot hold too much electron density, so it has to let it go. So these two electrons, the bond breaks and these two electrons move to B. But this A gets bonded with Y. These two electrons are used to make a bond with this Y and A. So now both these electrons, which was previously on Y, is now shared between Y and A, so Y gets a formal positive charge and B gets a lone pair and a formal negative charge. So this is the new bond which formed. So formation of new bond, this furnishes some of the energy required for heterolysis. So this was all about the bond cleavage. In the next video we will see the Bronsted-Lowry definitions of acids and bases and Lewis definitions of acids and bases. Thank you.